हाँ, so when we are giving the forward biasing to the PN junction diode at that time, at start there will be very less or no amount of current will flow with respect to voltage. But when the value of given voltage, ये forward voltage drop, ये जो x एक्सिस पे मैंने जो वोल्टेज दिया है, वी आर प्रोवाइडिंग, ये जो हमारे पास डायोड है, at that time if we are giving external power supply to the diode, we are saying biasing. And when you will give forward biasing, मतलब ये जो डायोड है उसमें तुम पॉजिटिव टर्मिनल ऑफ बैटरी पी को कनेक्ट करोगे, निगेटिव टर्मिनल ऑफ बैटरी हम एन टाइप सेमीकंडक्टर को कनेक्ट करेंगे, जो डायग्राम हमने लास्ट सेशन में देखा है. We have seen the working principle. So when we are giving the positive terminal to the p-type semiconductor and negative terminal to the n-type semiconductor at start, there will be no amount of current will flow. And when our supply voltage will reaches to the knee voltage or the cut-in voltage, that is nothing but 0.7 volt for silicon and 0.3 volt for the germanium. At that time, there will be sudden increment in current with respect to a voltage, and that voltage we are saying as a cut-in voltage. There will be the question in the exam, cut-in voltage define. At that time you are supposed to know the forward voltage at which there will be sudden increment in a current with respect to voltage. That voltage we are saying as a cut-in voltage. Now you all got this point? Please respond. आवाज आ रही है सभी को अच्छी से? समझ में आया है? हाँ, ओके ओके, इट्स फाइन, समझ में आया है? फॉरवर्ड कैरेक्टरिस्टिक्स आ गया है सबको समझ में? Okay, now we can move to the reverse characteristics. Now what we are supposed to do? Now here we are supposed to give the negative supply to the battery. If you want to see the diagram, I will show you. Just wait for a minute. Now here you can see when we are connecting negative terminal of a battery to the p-type semiconductor, what will happen in p-type? We are having the holes as a majority carrier. होल्स का चार्ज क्या है? पॉजिटिव. हम कनेक्ट क्या कर रहे हैं? बैटरी का कौन सा टर्मिनल? निगेटिव. सो निगेटिव पॉजिटिव विल गेट अट्रैक्टेड टुवर्ड्स ईच अदर. तो क्या हो जाएगा? द holes will go towards the negative terminal of a battery. And at the same time we are connecting positive terminal of a battery to the n-type semiconductor. In n-type semiconductor we are having electrons which are having negative charge and we are connecting positive terminal of battery. तो क्या हो जाएगा यहाँ पे भी? There will be the attraction in between electron and the positive terminal of a battery. So what will happen? When we are giving negative power supply to the PN junction diode, at that time, due to the repulsion between due to the attraction between negative terminal of a battery and holes and attraction between positive terminal of a battery and the electrons, the width of depletion region will go to increase. समझ में आ रहा है? यहाँ पे जो डिप्लीशन रीजन है उसका वेट बढ़ रहा है जब हम निगेटिव सप्लाई दे रहे हैं, व्हेन वी आर गिविंग रिवर्स बायसिंग. बट फॉरवर्ड बायसिंग में क्या हो रहा था? इफ वी आर गिविंग द फॉरवर्ड बायसिंग, ओनली इफ यू सी व्हाट इज द चेंज इन दिस डायग्राम, यहाँ पे सिर्फ जो पॉजिटिव टर्मिनल है बैटरी का वो पी को कनेक्ट किया है और जो निगेटिव टर्मिनल है एन को कनेक्ट किया है. ओनली बैटरी जो है उसके कनेक्शन ऑपोजिट किया है फॉरवर्ड और रिवर्स में. फॉरवर्ड में हम क्या करते हैं? पॉजिटिव पी को कनेक्ट करते हैं, निगेटिव इलेक्ट्रॉन्स का जो एन टाइप सेमीकंडक्टर है उसको कनेक्ट करते हैं. तो ड्यू टू विच द वेट ऑफ डिप्लीशन रीजन इज गोइंग टू रिड्यूस्ड and after some time the depletion region will get removed. और उसकी वजह से क्या हो रहा है? यहाँ पे there you will get flow of current without any disturbance. But in negative You can say negative biasing or you can say reverse biasing. So when we are giving negative power supply to the PN junction diode, what will happen? DR, the depletion region, will get increased in the reverse biasing. So here we are supposed to see the diagram for that. So now you can see here. When we are giving reverse biasing to the PN junction diode, at that time there will be very less amount of current will flow. If you see, you will get this in the third quadrant, because we are giving here negative voltage. At that time you will get negative current. दोनों value negative है, due to which we are supposed to draw the reverse characteristics in the third quadrant. Because on x-axis we are taking voltage, that is the reverse voltage, or you can say negative voltage. ये जो voltage है यहाँ पे तुम उसको माइनस भी लिख सकते हो या फिर VR लिख सकते, V suffix R means what? The reverse voltage. And when we are giving reverse biasing to the PN junction diode, at that time there will be very less amount of current will flow. And as here we are giving negative voltage and you will get negative current, you are supposed to draw this diagram in a third quadrant. And when we are increasing the reverse voltage, you can see here, जैसे जैसे हम वोल्टेज का वैल्यू बढ़ा रहे हैं वैसे वैसे करंट क्या हो रहा है? वेरी लेस अमाउंट ऑफ करंट विल फ्लो. And if you see in this diagram, you can see that current we can say as a negative current, because this current is coming in the third quadrant. When we are giving negative supply to the PN junction diode, at that time there will be the reverse saturation current will flow. This leakage current, or you can say saturation current, that is nothing but a negative current which you will not require, because this current is because of only minority charge carrier. माइनॉरिटी मतलब क्या? जो कम अमाउंट में होता है. तो when we are giving negative supply to the PN junction diode, what is happening? The weight of depletion region बढ़ रहा है, due to which there will be very less amount of current will flow, and that current we can say as a leakage current or a reverse saturation current. And when given given reverse voltage will goes to the breakdown point, you can see here at some point the amount of current will go to increase. That voltage we are saying as a reverse breakdown voltage. When the value of given negative voltage will goes to reverse saturation current, at that time there will be sudden increment in a current. You can see यहाँ पे current का value अचानक से बढ़ गया है, और जो point से बढ़ा है वो point को हम क्या बोलते हैं? वो voltage को हम क्या बोल सकते हैं? We can say that voltage as a breakdown voltage, because जो यहाँ पे करंट कांस्टेंट था, जो यहाँ पे बहुत लेस करंट था, उसका वैल्यू सडन बढ़ गया है. एंड हाउ इट इज increasing? It is increasing linearly. But if you see in the first quadrant, when we are talking about the forward biasing of a diode, when we are giving forward biasing to the diode, at that time when your supply voltage will become equal to the cut-in voltage, at that time there is a sudden increment and it is looking like a curve, exponential curve के जैसा दिखता है ये डायग्राम जो फर्स्ट क्वाड्रेंट का है. But in third quadrant, when the given supply voltage will reaches to the breakdown voltage, at that time there will be sudden increment in a current. But if you see that voltage we are saying as a reverse breakdown, but the reverse characteristics of a diode, these are not depending on a voltage, these are only depending on a temperature. So we can say here, when reverse voltage is going to increase, reverse saturation current will remain constant. That current we are saying as a reverse saturation current. ये जो If you see in the third quadrant, ये जो blue line है, which one? Horizontally blue line. That current we are saying as a reverse saturation current. And when its value will reaches to the breakdown voltage, at that time the value of current will go to increase, and that voltage we are saying as a reverse breakdown voltage. वो voltage को हम क्या बोलते हैं? Reverse breakdown voltage. So these are the VI characteristics for a PN junction diode. If you see in our syllabus, we are supposed to see PN junction diode and some special diodes. These are nothing but Zener diode, photodiode, LED. I have given short description about this yesterday. But here if you see, when you are supposed to draw the VI characteristics for diode or a Zener diode, तो उसका forward characteristics दोनों का exactly same है. Forward characteristics of Zener diode and simple PN junction diode are same. But if we will talk about the reverse characteristics of PN junction and reverse characteristics of Zener diode, these are abruptly different, because here यहाँ पे after reverse breakdown voltage in PN junction diode, the value of current will go to increase, but it is not constant. But if you see in the VI characteristics of Zener diode, at that time you will get here at the constant voltage of for some time there will be increment in a current. मतलब voltage constant रहेगा, but वहां पे क्या हो रहा है? Voltage constant है, current का value बढ़ रहा है. So we can use Zener diode as a voltage regulator. Regulator मतलब क्या? जो हमें constant एक value देगा. So the best application of Zener diode is nothing but a voltage regulator. And if you are supposed to use diode for a forward characteristics, at that time you can use only PN junction diode. We cannot use Zener diode, because Zener diode is giving application as a voltage regulator when it is in a reverse bias. And when we are giving forward or reverse biasing to the PN junction diode. In forward biasing, you will get very increment in a current, due to which we can use here diode as a switch. If there will be question in exam like the best application of a diode, we can use diode as a switch, and we can use Zener diode as a voltage regulator. Okay, now after diode we are supposed to see about the rectifier. So do you have any idea about the rectifier, or from the name rectifier? किसी को कोई idea है what does mean by rectifier? Which electronic device we can say as a rectifier? Is there anyone? No one is there. Okay. See here. What? Very good. To convert current only, that is not enough. But the guy who has said AC current will be converted into DC, that is exactly correct answer. So we can say rectifier is nothing but it is a device which can convert AC voltage or current, voltage या फिर current. If that will be converted into DC voltage or current, at that time we can say that device as a rectifier. Here about the VI characteristics, there is an explanation given. You can see in the forward region, if you see when we are applying the voltage, at that time for some time you will not get any amount of current, but when voltage will reaches to the cut-in voltage, there will be increment in a current. You can write in the forward region. In reverse region, if you see when we are connecting negative terminal of a battery to the p-type semiconductor, positive terminal of battery to the n-type, we can say that biasing as a reverse biasing, and that region we can say as a reverse region, and that will be coming in a third quadrant. Again, saturation is nothing but this region is also coming in the reverse region, because if you see at that point you will get very less amount of current, and that current we are saying as a reverse saturation or a leakage current. After that, breakdown region. Which region we are saying as a breakdown region? The part of the reverse region. This is also a part of reverse region. If you see in the reverse region where you will get very less diode impedance, and here current amount will go to very high. You can see here the diagram. ये जो करंट का वैल्यू सडन बढ़ रहा है, that region we are supposed to say as a reverse breakdown region. Now, threshold voltage. Threshold, you are supposed to uh, point out these words when you are attending the lecture. At that time, you are supposed to put your one notebook and one pen with you and the short points, because these are the tricky questions you will be get in the MCQs. So, threshold voltage, knee voltage, cut-in voltage, barrier potential, but barrier potential only for diode. When the voltage will exactly become equal to barrier potential, at that time there will be increment in a current in the forward biasing, and that voltage you are supposed to say as a threshold voltage. वो वोल्टेज को हम क्या बोल सकते हैं? थ्रेशोल्ड वोल्टेज. जो वोल्टेज से करंट का वैल्यू डायरेक्टली इंक्रीमेंट हो रहा है. तो if there is a question, threshold voltage for germanium, that is nothing but a 0.3 volt, because from 0.3 volt if you see, value of current is going suddenly increase with respect to voltage. Because of that, that voltage we are saying as a threshold voltage. तुम उसको threshold बोल सकते हो, knee voltage बोल सकते हो, cut-in voltage बोल सकते हो. Okay, now we are supposed to see about the saturation current. Which current? When we are giving negative supply to the PN junction diode, at that time in the reverse region, there you will get very small current. That current we are saying as a saturation current, and its value is very less. So if you see this diagram, see here, please concentrate here. Bija Kiran. What is this language? See here, what we are supposed to see here, when we are giving the negative supply, at that time what is happening, there is a very less amount of current is flowing. That current we are saying as a reverse saturation current. वो current को हम क्या बोलते हैं? Reverse saturation. And that current is very small. So when there is a question, you are supposed to draw reverse characteristics. तुमको सिर्फ इतना diagram draw करना है only for third quadrant. And on the x-axis, you can give here VR, reverse voltage. And on the x-axis, on the y-axis, on the lower side, downward side, ये जो voltage है, हमने negative दिया है, तो हमें यहाँ पे जो current मिलेगा, what will be? You can say that current as a IR, and its value is very less. So you can give in a bracket microampere. If there is a question in exam like the value of reverse saturation current is, and there will be 4 options: microampere, ampere, kiloampere, none of these. At that time you are supposed to understand reverse saturation current जो होता है वो बहुत less होता है, so that will be in the microampere. And forward current only ampere. Forward current का value बहुत बढ़ रहा है, so that is in the ampere. But reverse saturation current will be very less, so you are supposed to measure that in a microampere, or that can be in a nanoampere also. Now see here. So we can say saturation current is nothing but it is very small due to the drift current. So what does mean by drift current? When we are giving external power supply, there will be the question in exam, because in our syllabus they have given one topic as a drift and diffusion current. Drift and diffusion current. So what does mean by drift current? Drift current is nothing but when we are giving external power supply to the diode. At that time, there will be the motion of charge carrier, and that current we can say as a drift current. जब हम उसको एक्सटर्नल पावर सप्लाई दे रहे हैं तब क्या हो रहा है, चार्ज कैरियर मूव हो रहे हैं. कहाँ मूव हो रहे हैं? पी टाइप के एन टाइप में एंटर कर रहे हैं, एन टाइप के पी टाइप में. सो दैट करंट वी आर सेइंग एज अ ड्रिफ्ट करंट. एंड व्हाट डज मीन बाय डिफ्यूजन करंट? डिफ्यूजन इज नथिंग बट it is a current in a semiconductor diode that is because of diffusion of a charge carrier. Diffusion of charge carrier is nothing but the transporting of a charge carrier from p type to n type and n type to p type. But if you see, for drift current you are supposed to give external power supply, but in diffusion if you are not giving power supply, only we are taking one unbiased मतलब मेरे पास सिर्फ डायोड है, मैंने उसको कोई भी पावर सप्लाई एक्सटर्नल दिया नहीं है. एट दैट टाइम ऑल्सो देयर इज अ attraction of holes towards the electron of n-type semiconductor, and electron of n-type semiconductor will attract it towards the p-type semiconductor. तो वहां जो पोटेंशियल क्रिएट हो रहा है वो पोटेंशियल हम क्या बोलते हैं? बैरियर पोटेंशियल. And that region when holes will live, at that time they will live behind their निगेटिव आयन एंड इलेक्ट्रॉन्स यहाँ पे पॉजिटिव आयन. तो वो जो निगेटिव और पॉजिटिव इमोबाइल आयन का एरिया होता है उसको हम क्या बोलते हैं? डिप्लीशन रीजन. और डिप्लीशन रीजन में जो वोल्टेज क्रिएट हो रहा है वो वोल्टेज को हम क्या बोल रहे हैं? बैरियर पोटेंशियल. सो व्हेन वी आर नॉट गिविंग एनी एक्सटर्नल पावर सप्लाई बट देयर इज अ डिफ्यूजन ऑफ अ चार्ज कैरियर, there is a transportation of a charge carrier, and due to which current is produced, that current is nothing but a diffusion current. Have you got diffusion and the drift current? Drift current कब? जब हम external power supply दे रहे हैं. At that time, if there is a motion of charge carrier, if there is a transportation of charge carrier, at that time that current we can say as a drift current. Okay.